we go. So I don't know who has the, is it Flores Doran that can record this? I don't have permission, you see. Please ask the host to give you permission. Who's the host? It should be Paul. Is Paul here?
Let us someone else.
See, this is why I have my backup plan, because yeah, someone asked him to come in and record the class. So all I've talked about so far, if people are still coming in, I just reviewed the syllabus that I sent you. Oh, and I need to tell you something. I need to tell you, am I still sharing screen? No. I need to tell you what I'm going to do with the grading. Okay, so the first week you had with Professor Henderson, there's Delcy. And so that's 1 week out of 5 weeks. And so we are going to divide up, oh, look, I said 3. This should be, for me, it's going to be 4 equally. Sorry, I said 3. It should be 4 equally weighted assignments that I will give you at the end of the class on Sundays, and then you should submit it to me by Thursday before the class. And that's it. It's going to be 4 equally weighted assignments, and Professor Delcy is going to be giving you one of his own, so each one is worth 20%. Okay, so that makes sense. So each week it will be 20% value for your final grade. Any questions? No? All right. So I have to set up, I'm trying to set up my...
Some question on the chat.
You have a question?
No, there are some questions.
Okay, sorry, let me see the chat. Thank you, sorry. Let's see the chat. Oh, you like YouTube? Oh, some people like Zoom. So what I'm doing, I don't mind going to YouTube. I already have it in YouTube. Do you want to go to YouTube completely, or we can finish here this day and then tomorrow we can start in YouTube? If you look, I've already put it in YouTube. Let me see. In the same, see? I don't know if you can see that. Let's see if this is going to be. See, I'm already streaming in YouTube. You can see that. So this is MBA UNDH Finance, and it's under in the same. Do you want me to send you the link? I have to send the link. It's in the same link that I gave you last time. Let me give you this link. I'll put it in the chat. Or you know what I'm going to do is I'm going to get the link for this one. So this is where you go each class to find. It changes the name though. I don't want this one. So here is, oh, Paul's here to record. Yes, so everything is going right to YouTube. I'm just going to set up my whiteboard to begin streaming the documents. I'm here. I'm just preparing my documents. How's the sound? Sound is good?
Sounds great.
Oh, good. Okay. So what I'm going to do is, all right. I'm just having a little issue, technical issue with my whiteboard. I have to think about why. Okay, I know why. So many details. So many things to check to make sure this thing runs properly. Okay. All right. And there we go. It's not recognizing, my whiteboard isn't recognizing my computer. Why is it not working? Not good. I don't know. I have to put it close to the computer. My iPad is acting up. I don't know why. I probably have too many signals. Oh, I'll leave this on the screen for now so that you can have something to look at while I sort this out. I can show you also these. Let's open. I can show you this. There we go. So these are the notes that I gave you. Maybe I can get away with just using this. So you can see that? So those are the notes that I gave you. And they're quite long, like 88 pages. And we are going to get through this in the next couple of days. So you guys can mark up. Did I do that? Mark up the page? I don't know. Let's see how that happened. Anyway, let's so I asked Doran to ensure that you had a financial calculator for this quantitative course. Were you able to get a financial calculator? I don't know what this thing is here. How do I erase this blue mark? I don't know. Somehow there's a mark. All right, so if you didn't purchase a calculator, or I have given the options that you You can get a calculator, a TI BA2 Plus calculator. This is the one that I have the instructions for. But really, any finance calculator should be able to do the comparable calculations. So I'm going to work with the calculator. I'm going to work with formula and explain to you how to solve problems using both. But I have to begin with a setup of the calculator. I am not going to teach you in Excel, but you could also explore that as an option. That's not my preferred method of instruction. I'm still trying to set up something. So if you don't have a calculator, I mentioned to the group, the administration, that you can, on a smartphone, you can find a finance calculator. And I want to tell you which ones you can get. Let me write it here. So there's the TI BA2 Plus calculator. That's the Texas Instrument calculator. That's the one I'm going to use. That's the one you're going to see the notation for. But you could just as well use any finance calculator, but it has to be a finance calculator. What I'm doing is not necessarily you're not going to be able to you're not going to be able to follow the steps for the finance calculator on a scientific calculator. That's the point. So this is the calculator I use. What do any of you have a finance calculator?
Yes, I have one.
Yeah? Okay.
Yes, I do.
Okay, very good. Okay, so some people have it. Very good. But do you have this one or a different one?
Want me to-
I have this one from application store.
The same one, the TI.
Exactly.
Oh, perfect. Okay, so we're going to be good. We're ready to go then for some people. And others, you can find this application on a smartphone. If you didn't buy the physical calculator, which costs, I don't know what it costs over there, but it's not too bad. But you can buy it on a smartphone for half the price, or a fraction of the price. I'm just typing in the notes because I'm not able to get my iPad working right now, but it's okay. So as I'm teaching you, I'm restarting my iPad. And, okay, so what we have to do to begin is to set up the calculator. At the beginning, it's not going to make too much sense why we're doing all of these steps, but it's imperative that you make these steps, okay, to clear your calculator, to begin with a clean slate. So there's different kinds of clear functions. If you, this is the most extreme, clear all. Clear all swipes all the memory of your calculator and literally leaves it in the manufacturing default settings. You don't want to do that unless something's wrong with your calculator, or you can do it right now just to practice doing it, but you don't routinely want to use clear all. That's a hard reset. It's very hard to reset, and it's only in extreme conditions. I've taught this course for 20 years almost, and only once did a student actually have a broken calculator, and she couldn't fix it with hard reset. But usually a hard reset will reset it back to manufacturing settings. So to do that, you hit second, reset, enter. And I want to demonstrate the calculator to you, but for some reason I cannot open my iPad. I'm not sure. I'm thinking that, I don't know if it has something to do with the Zoom. So weird. I'm going to try. Let's try this. I found it. Oh, finally. Finally. All right, so I'm going to show you. It's still having trouble connecting. I don't know why. Okay, I think it did it. Lots of steps to this. Oh, no, it said it didn't like it. Gosh. Oh, there's some sort of interference. Okay. Here we go. Are you watching my screen right now? Can you see what I'm doing? Trying to find. That's not it. There. Okay. There we go. Can you see that? Do you see the calculator?
Not yet, teacher.
No? Oh. Okay. All right, I know what I have to do. Once I get this all going, we're going to be fine. All right, there. Calculator. Got it? All right, so this is the calculator. This is the TI, Texas Instrument BA2 Plus. Is it visible?
Yes.
All right, so I'm going to press slowly so you can follow along. So for the hard reset, it's second. What was it again? It's second reset, enter.
Enter.
Okay. So second reset, you see where that is down here? And then enter. And it's reset. It's back to manufacturer settings. Again, second reset, enter, and it's done. Oh, but see, it says question mark because it's already reset. All right, so I keep hitting down here CEC. That clears the screen. It does not necessarily clear memory. It just clears the screen, all right? So I didn't put that in the list, but that's another one. Now let's see. So you just see the calculator right now? Let's see if I can share.
Yes.
I'm going to show both the calculator and the steps, right? The slide. Okay, you can see my desktop now. So how's that? You see the calculator and the
Yes, we can see both.
and the notes. All right. All right, so now in this row, the third row, you see N, I, PV, PMT, and FV. That is the time value of money row, the TVM row. That is what we're going to use primarily for finance. Now there's other functions in here, but we're going to use this one a lot, at least this weekend. So this row here is called the TVM row. Now you might, right now I have nothing entered, but I might have things in there, and I want to reset before I do my next problem. So to clear it, so let me put some things in there. I'll just put that for now. So to clear the memory, I have to just to clear that memory, not to do a hard reset and not to clear any other memory. I just want to do second and clear TVM over here. You see that? And that'll simply clear this row. So now it's empty. I had put a 4 in here. So as I said, I'm going to teach you this now. This page is very important. It might not be important right now, but it's going to be important. So keep it handy. You might want to print it. Okay, now you want to clear, okay, so then there's several sources of memory, several memory banks. One is this TVM row. Another one is a worksheet. A worksheet can be, there's a variety of worksheets. One is from cash flows. You see this key here, CF? This key, I can enter cash flows over several periods. And you see I can put the first one and the frequency, and then sorry, it's not going to let me put any more. I have to put them in. But anyway, let's say I put something in there. I should enter some things. So I'm going to put some numbers. Okay, so there you go. So there they are. I've put in some cash flows, and I want to make some calculations with them. There's some functions that are programmed into the calculator. And then I want to do another problem. So to clear this, it's not enough to hit the clear key. That's not good enough. That clears the screen, but look, it's still there. So I want to actually clear that workbook. To do that, I have to be inside the workbook or worksheet, and I have to hit second and clear work down here. Now it's clean. If I scroll through, it's empty. All right, so that's clearing the worksheet. There's another worksheet. There's statistical data here. Statistical data is with data. If I hit to activate data, currently there's nothing in there, but I can start entering values. If you remember from statistics, did we do this in statistics? I think we did. So you could start entering values like that, right? And you can get some statistical results. So all I'm showing you is that there's data in there. Now this is a different worksheet than the other one. So what I have to do is, I can't just clear the screen. That's not going to work, because as soon as I touch the worksheet again, it's still there. To clear it, I have to be inside of it and then hit second clear work. And we have to do it that way because there's many different worksheets on this calculator, or in this calculator. All right, so I've done the first 3, and now I want to set the decimal places. This is very important. Well, all these are very important. I keep on emphasizing this is an important list of settings that you have to do. Decimal places are really important because we're going to work with interest rates. We're going to work with interest rates, and we want to keep as many decimals as possible in our calculations, okay? And we want to observe them, we want to see them. So to see them, right now I only have 2 decimal places on my screen. I want to see as many as possible. The most you can see on this screen are 9. So what we're going to do is tell the calculator I want to see 9 decimal places. To do that, you hit second, format down here, tell 9, and enter, and you're ready. So now if I make a calculation, let's see if I do 1 divided by 9, I can see 9 decimal places. If you hit the hard reset at the top, you'll lose that and you'll have to reset it again. So don't do that. Hard reset will reset everything. All right, question so far. Should I do it again? Second, format, 9, it's already in there, and enter. And that makes me have 9 decimal places. Let me see if you have any questions. That's not it. Oh. Where'd you guys go? Sorry, I can't find you. I want to see the chat. Yeah, I'm not a Zoom pro. Okay, no questions. Very good. All right. My display. I want this and my instruction sheet. Okay. And I'll put the chat down here. So yeah, I should arrange all of this. There we go. That works. Okay, so then the next thing we want to do is we want to tell the calculator that when we compound, so I'll explain what compounding is if you don't know. When we want to compound interest, we want it to compound interest once per period. We want the period of compounding to match with the we want it to match. We want, if we have an interest rate, that interest rate represents the interest rate over the period. So whatever I put into I here, this is for interest rate, for instance, for example. Now there's other places I put interest rate, but just to say, whenever I press an interest rate on this calculator, it's going to assume that that is the same frequency for which payments are going to be made. This one over here. This will all make sense later. So what you want to make sure is that this is 1. It's compounding once. And some calculators have it set already, but some don't. So let's make sure. So second, PY is right here. And then tell it 1. See, it's already set to 1. And enter. So it was already set on this calculator. Finally, the last step is to make sure your calculator is compounding your cash flows or your amounts, your payments, or whatever it is that you're interested in, that those are occurring at the end of a period. Now that's not necessarily the case, right? Because when you pay your mortgage, you pay at the beginning of the period. When you pay your when you pay up front, that's different than when you pay at the end, like a phone bill. Okay. In general, though, we're usually going to use end of period payments, and sometimes we're going to learn, for those few times, we're going to learn how to deal with beginning of period payments. All right. So the calculator is already set in the end mode, and you can see that if I hit second, you see BGN BGN stands for begin. And then you tell the calculator enter. You tell it second, sorry, and set. You don't tell it enter. You're hitting enter, but it's set. What happens here is the calculator has been shifted into payments accumulating at the beginning of the period. Payments being made at the beginning, and that's a different calculation. So you see in the top right end of your screen, it says BGN, begin. Now, as I mentioned, most of the time we're going to deal with cash flows or amounts at the end of period. So we need to turn that off. It's still on, you see? Even if I clear the screen, the BGN is still there warning you, you have to reset your calculator. How do you think we reset the calculator? See if you can figure it out. How do we return the calculator to end mode? No one?
The second thing.
Do the same thing. You do the same thing. This is a toggle button. You repeat. Second,
Your work.
begin. Second,
TVM.
set. No clear TVM. Clear TVM would just clear TVM. You have to repeat. So just repeat. So repeat the same steps to get rid of it. Again, if you don't understand exactly why we're doing this, it's okay. It's going to make more sense later. Anyways. Okay. Questions? Any questions? I don't want to see that. I want to. There we go. Let me see the chat. No questions? Okay, so we're ready. Our calculators are set. And we are moving on. Let's see. My calculator's ready. You see, I don't have any begin in the upper screen. It's clear. Okay, let's see what we do next. Okay, so the calculator has another set of storage keys. So we've already talked about the keys for our cash flows. I mentioned the TVM, and I've mentioned the memory for the statistics. But there's also a storage. There are 10 storage slots. And you can access them by pressing $, the key stow. Uh-oh. My computer. I lost connection. Hold on. And I have to reconnect. 1 second. Why did it do that? I don't know why. Not sure. 1 minute. Maybe we can take a break and just go to YouTube if this continues, because it might just have, I don't know, possibly to do with being in Zoom. I don't know. Well, I'm having trouble today. Okay. Let me get this down. So you see, what we're going to do now is I'm going,
Storage.
pardon? Can you see?
É bom. Olha ali. Avancei.
Okay, so let's, what we're going to do is we're going to store some numbers. We're going to store the number 9. I want you to store it in stow 1. So you're going to hit, oh dear, let me close this. Excuse me, I have to close, sorry. All these personal things here. Okay. So 9, stow 1. So 9, and then stow and 1. So that has been put into the storage, the 1 slot. I think I can store 0 as well. I don't have it here, but I think we can do that as well. All right, so then I want you to put 11 I want you to store it in 2. So you have 11, you press the number and then stow 2 and you can clear the screen. Now let's see, well, how can I view those values? I can use recall. This is RCL to see those numbers again. So recall 1 was 9, right? I can recall 2 was 11. Okay, so should I repeat? So this has now activated the storage. So this is another worksheet. If I want to see the values in memory, I can hit second and memory and scroll through. So M0 is that's another storage space, memory 0. But I entered into memory 1 the 9 and to memory 2 the 11, and there's another bunch of storage spaces that are empty. Okay, so there's 10 total, 0, 1 through, do that again, 0, 1, 2, all the way to 9. If you want to clear that, I think second clear work. Once you're in, so let's say we're here, so there, if we hit second clear work, it should clear, and it does, you see? So I'm in another worksheet. So far there's several worksheets. We have the cash flow worksheet, we have the statistics worksheet, we have the memory worksheet, and we have TVM. Okay, so we will use that again and again, so you'll get practice. I should put there's a 0 as well. Oh. So you use stow for storage, and then you can recall. So we can make a calculation. We can recall we can do recall 9 divided by, I say divide, I say times, multiply recall 11, recall 9, recall 1, sorry, recall 1, and multiply it by recall 2. What do you get? What is your answer? Well, I erased everything, so let me put them back. So let's do this again. So I'm going to put 9 stow 1 and 11 stow 2. And now I'm going to compute recall 1 multiplied by recall 2. And recall, what happened? Recall 1, recall 2. Okay. Recall 1 multiplied by recall 2. It's 99. So this is my example. Oh, question. Oh, that's interesting. It just pops up. Go ahead. You have a question, Jean? I can't hear you. That's very good though. It popped up and I couldn't ignore it. Ernst, Jean, you have a question? I can't get rid of this now. Let's put it here. I have to put your hand down.
Yeah, good afternoon, teacher.
Yes, hi.
Good afternoon, everyone. So I want to ask you a question.
Yes.
So let me know if you pose the question, the onward question as you did in the statistic course. You be our platform.
No. We will just work you mean for the test?
Yeah, for the test also.
No, I will send it to you and you have the week.
Okay.
It's better?
Okay, that sounds great.
Okay, good. Very good. Yeah. You have time to work. Okay, so that's my example for storage. All right, so let me put your hand down. Can I ask okay, lower the hand. Okay, otherwise I can't put this away. Well, that's good. It forces me to answer questions. Okay. Next. Okay, when we are talking about cash flows, we have to think of cash flows in terms of whether they are inflows. In that case, they would be positive cash flows, or are they negative cash flow? So a cash flow or outflow, it would be a negative. So inflow would be getting money, receiving payments, receiving income. Those are cash inflows. Cash outflows would be making payments or paying salaries to employees. Those are cash outflows, all right? The calculator needs to know what kind of cash flows you are entering into it. Is it a positive or a negative? This is really important in the valuation using the formulas that I introduced you to. It's very important that you keep track of whether the dollar amounts you're entering are inflows or outflows. Okay? So to do that, you use this key here that I will, this key here will make it positive or negative, right? All right, so we're going to begin with a discussion about time horizon. And it's 6 o'clock, o'clock. And I'm thinking, let's take a little break because I'm just gonna clean up my iPad. Let's take a few minutes. Let's take 5-minute break before we get into this. Oh, and you can ask me some questions if you have them. I'll be here. Any questions? I just want to clean my screen. Okay, that's all right. Most of the stuff is hidden. Okay. No questions? No comments? Let's take a break?
Professor,
Yes. Ulrich.
the assignment given by Professor Delcy will account for 20%?
Yes.
Okay.
So his assignment is 20 and mine will be 20. Each one.
Okay.
So it's 5 assignments of 20.
Thank you.
Thank you. So you can ask me questions. I'm here. I'm just giving a little pause so people can get organized. I maybe put my video on, but then it's okay. I'm gonna watch things on YouTube on my phone, see how it looks. So on YouTube, it's not looking so hot. You just see that. You just see the calculator. That's not good. Okay. And then I lost connection again. Okay. So let's see the YouTube stream. What's going on? Because that's not what I want. I want that. That's what happened. Oops. So YouTube is not gonna have a good view. Oh no. That's funny. I have to figure out a way. Well, let's go to, let me see. Yeah, for some reason, if I share the screen, how do you guys feel if we just go to YouTube now and we'll ask Paul to give me this video and I can put this video up on YouTube as well? Is that all right? Because, yeah, if we go to YouTube, if we just break a moment and then I continue in YouTube.
Good idea.
Okay, so you guys, let's get off of here, but we still need the recording. So I need the recording from Paul, and then and we'll meet you on YouTube in a few minutes by 6 o'clock. Okay, so I'm gonna stop here.
Okay.
I'm gonna close this. Bye from here. calculator. All right. I'm watching all my adjustments. Oh. Why do I have two calculators? I have two calculators. Oh, I guess I can just do this. I'm gonna do Okay, you see me on YouTube? Let's see. And I'll send you guys the link. Aha, you made it. I see you. Very nice. All right. So otherwise there's too many things for me to observe, and I much better here. And I can see your chat, the chat. Very good. Hello, Louis. Jeff Day. All right, so this is where I left off. And now I can use my pen. Jeff-san, very good. I sent the link. I'm going to send it to the couple of people that don't get it. Just waiting for people to come in. I feel better here. Very good. I'm glad. Glad you hear me. And I feel much more in control in here. It's just a matter of what you're used to. And I'm just sending one more email because some of the email addresses were not clear. Okay, we're going to talk about horizon time. Now this seems very elementary, but it's very important that we get things straight about the timeline. For time value of money. And what does this even mean? What is time value of money? So this is how we're going to look at 2 periods, and then onward it's the same sort of thing. I'm going to wait till I see more students. It's only 15. So what I'm going to do is put the other video from the recording up as well. So that's a better video than the beginning of this one because when I started to share the screen, it appears it didn't transmit in YouTube very well. Okay, some people are coming. Okay. Okay, so what we have here is the timeline over 2 periods. We'll call this one period 1 and this one period 2. Very elementary, right? Okay, thank you, Jefte. And we're going to begin here. Begin now is time 0. Period 1 transpires, and this is the end of period 1. But it's also the beginning of period 2. So period 2 transpires and then it terminates in period 2, end of period 2, which is the beginning of period 3. So easy, right? So when I talk about end of period payments, I'm talking about these marks here. This is the end of period 1. This is the end of period 2. Let me just wait. I still see the numbers climbing, so I'll repeat myself. See if a couple more people come. So each day you can find the link in the YouTube, the original YouTube video, playlist. I'll send an email tonight with the playlist link, and you can always go there and find us every day that we meet. Okay, it looks like the students have stabilized. Okay, so again, we begin here. Now, right now is the beginning of period 1. You can also think about it, and every single mark on this timeline, you can think of it as the beginning of something, but it also is the end of something. And this would have been the end of period 0. Beginning of period 1. Period 1 transpires and terminates in 1 here. So the mark of 1 denotes that a period has passed. Okay, so it's like a birthday, right? You're born and then your first birthday. So that's a way to remember. So this is both the end of period 1, but it's also, every position has 2 perspectives. 1 as the end of something and 2 as the beginning of something. So this is the beginning of period 2. Period 2 transpires and ends in end of period 2. That's the mark of 2. However, also you can think of it as the beginning of the 3rd period, whether that occurs or not. All right, let's continue. You're going to see this a lot. So here we have very basic time value of money, and I will do my best to explain the time value of money concept. So I'm just going to start here, but I got to go back a little to talk about what all this is. What is the time value of money? If you were to take $1,000 and invest it today, how much would it be worth in 2 years' time? Well, it depends. It depends on the willingness of someone to, or someone or some entity to pay you for your investment, right? Your willingness to give up $1,000 today and invest it for 2 years and not even see that money has a cost. The way I've written this up is there's somebody prepared to pay 18% per year to you for you to invest that amount today. And that's what we're going to use as the interest rate. In fact, or the rate of return. In fact, there are many prevailing interest rates available. Which one we pick depends on our risk, our alternatives, really, our opportunity cost. If we find somebody who's offering 8% for $1,000 invested today, and we like that, it implies that if we weren't investing at 8% with this individual or this company or in this project, you would be able to search out 8% from somewhere else. So the idea is 8% is your target because that's what you're willing to trade off $1,000 today. So what you're doing here is you're seeing $1,000 now set away for 2 periods. I want to do this without the numbers. Let me try the one below here. I think it's here. So I'm going to start here with a clear sheet, okay? So we have a clear sheet. And we have the $1,000. And I want to ask you 2 questions. Well, 3 questions. What is $1,000 invested today worth in 2 years? Now, I already showed you the answers, but I'm really interested in the process. How much is $1,000 invested today worth in 2 years? How would you figure that out? And once you get that, I want you to tell me how much is simple interest and how much is compound interest, because they're different. if you invest $1,000 today at 8%, it means that you will, after 1 year, accumulate 1,000 and then %8 on the 1,000. Is everybody okay with that? So after 1 period, you will accumulate that amount. Now you can calculate that, but what I'm really interested in is in the pattern. You can imagine factoring that out and it would look like this. Does everybody agree with what I've done here? These are the same amounts. So the 1 here really represents the principal amount, the $1,000 that you invest, and this is the return. So if you were to put this, we're going to use the financial calculator in a moment, but if you just use a scientific calculator or the scientific keys, to calculate this is not hard, right? You can just do it in your head. This is just $1,080, and I know you guys are good at math. So that's what it would be. So after 1 period, I'm going to be going very slow, so be patient with me if you know the answers. Just be patient with what I'm trying to develop here. So after 1 period, this amount is reinvested, and the same thing happens. Now it's going to be in the second year, it's going to be 1,080 plus 1,080, times 0.08, correct? Let me do that a little cleaner. So it's the same principal amount, this, but then I add 8% on the whole amount. But that's the same as, well, that would be the same as 1,080, 1.08. But again, what is this? Well, this one was just this one, right? So I could write this, so I'm looking for a pattern, and the pattern is that after 1 year, I have a factor, this is known as an accumulation factor, of 1.08. And you can imagine there's just a 1 here. And after 2 periods, there's a factor of 2. So you see the pattern, what's happening. So that's an accumulation factor of 1. That's for 2 periods. So these coincide. What's really important is that 1 period passes. If 2 periods passes, you have 2 accumulation factors. And you get an answer. So you can put this into your calculator as well and get the answer. I'm going to teach you how to do this very easily. So if you put this into your calculator using just your regular know-how, you get that. Let me do it for you as well. Is this not high enough? There you go. Okay, so this is just mathematics. Let's do this in our calculator. I'll show you how to enter it with the scientific keys, and then we'll talk about using the TVM keys and the interpretation. So if I do this on my calculator, I have to clear the screen. 1.08 to the power, so I use this button, y to the x, 2 equals, and now I multiply by 1,000. So that was the accumulation factor, and I multiply by 1,000, and that's how I get my answer. Do you want me to see it? You want to see it again? 1.08, no, that wasn't it. 1.08 to the power 2 equals, and then multiply by 1,000. So I do the brackets first. You don't see my whole calculator, hey? How do I? Oh, I have to do something here. So you can see my whole calculator. 1 minute. Is that better? Okay. All right, so this is not hard. This was straightforward. We're going to go a little more theoretical in a moment. First, I want to ask you, okay, we've answered the first question, so let's put the answer, and then I'm going to ask you the other question. So the first answer is, how much, what is it worth? Okay, so the answer is, for A, the worth is 1,166.40 cents. What is the simple interest and what is the compound interest? I'll give you a moment to think about what I'm asking. What is simple interest in this problem? So we invested 1,000 and we got our money back, but we got something extra. 166.40. What portion of that is simple interest and what portion of that is compound interest? No idea. Make a guess. Make a wild guess. Okay, simple interest is 80, someone says. One first period is simple interest. Second is compound. Compound 640. Okay, good. Okay, some of those are right. All right, so what is simple interest? Simple interest is ignoring the effect of compounding. If I take, let me put it in general. If I take my principal amount, which I'm going to call principal value or present value 0, I multiply it by the interest rate, and then I multiply it by the time. That's simple interest. So in our case, it's 1,000 times 0.08 times 2, which is 160. So that is the simple interest. So you can remember that as a formula. And you should remember that and you should remember that I've ignored the compounding effect. I'm just looking at the effect of the interest rate. I'm not caring. If I'm just interested in simple interest, I'm not paying attention to the interest amount of the extra $80 that's created here, right? The compound interest yes, another way to say that exactly. It's 80 plus 80. That's what this is. It's two 80s. And the 80 is from 1,000 times the interest rate. Very good. Right. So compound interest, however, is the remainder, right? It's going to be the total interest minus the simple interest. Actually, you know what? I'm going to put that over here. Let me put that over here. So you have the formulas over here. So compound interest is equal to total interest minus the simple interest in this case. The total interest was 166.40, right? Everything other than the 1,000 minus the simple interest of 160, which gives 640. What's another way you can calculate that? So it's going to be here, just 640, but also you could have gotten that by taking your present value amount times your interest rate to the power of time. Okay, so it's just taking this is an easy way to calculate it, but it's just taking the interest rate as though the interest rate is compounding and compounding. The power, the factor, the exponent is what creates compounding effect. So in words, we say this is the interest on interest. Okay, so we see a pattern. What is the pattern? We are using this pattern to find what I call a future value. This is the future value in time t. In this case, it's 2 years. 2, so we'll put a 2 here. It's a future value at time t of what? Of a present value at time 0 times 1 plus I to the power of how many periods have transpired. So this is the general formula that I will refer to as the time value of money formula. And still you don't really understand that. I mean, I haven't really talked about what is time value of money, but let's start here. Okay, so let's feel confident we know what this means and where it comes from. Okay, so for this part C, Luxo is asking, what did I do? I'm just talking about the interest, not the 1,000, just the interest, because, okay, let me write that too. So total interest okay, the total interest is just the 166.40 because the 1,000 is the principal returned, so that's not interest. No mistakes. Did I make a mistake? And C, 640. I don't see a C mistake. What am I missing? Okay. No, there's no mistake. Oh, maybe on the other sheets you guys see something different. So the point is that the 1,000 is not interest. When you get your $1,000 back, you're getting your principal back invested. The interest is just the extra. So the interest is just the 166.40. Okay, hold on with your questions a second. I'll get to all of them. So this is the interest. Now, total interest then is this minus the simple interest, and that leaves 640. And let me just show you here. Do I say it here? Yeah, I do. Okay, so I have everything there. So your misunderstanding is that you're thinking the whole amount is interest. That's not the interest. That's the investment, the value of the investment, the future value of the investment. So this one is future value. The only mistake I see is this is a 1 here. So that's future value 1. But this one here is future value 2. So let me circle some results. So this is the first one. And then this is the second one. Right? And the interest is everything other than the 1,000. So that's 166.40. Right, earns. Okay, it's good you're sorting it out. So we have the 1,000 plus 80 is 1,080, and then we invest that again, and so the 1,080 we have the second period plus this interest that we earn. On the 1,080 again. So basically what you have to remember is it's $1,000 investment, and anything beyond that is interest. So this is, we start with 1,000 and we get 166.40 as the interest total. Sorry, I'm not seeing where the distress is. Okay, Ernst. Once verify the calculation again, please. All the numbers are the same. I don't see the mistake. I do not see the mistake. There is no mistake. Where's the mistake? I'm just looking. Anyway, usually my notes have all the calculations given. This was just an attempt for me to write it out for you. Do you see the steps and the derivations of the formula? But that is correct. 1,000 invested today grows to be 1,166. 166.40 is the interest that's made up of simple interest and compound interest. And this is the simple interest just ignores the effect of the accumulating on top of the interest, the $80 in the first case. And that's basically what's happening. So if you don't see it, I don't see any errors. 166.40, 166.40. Right, the 166.40, the total interest is your return, dollar return on investment. Getting your money back is not part of your return, right? You're just getting your money back. So this is the dollar return. Okay, so you start with 1,000, you have 1,166.40. This amount, 166.40, is the total interest, which is made up of the simple interest and then the compound interest. Now you might sometimes, it's okay, Luxo, it's okay, because actually I've made mistakes with this question before, so that's why I'm hesitating and taking your question into account. Together, these make the total interest. All right, so we got a lot out of this. We have our formula for time value of money. And we have, I'm going to bring in an extra page. So what we have here, so which one do you prefer? Option 1 or option 2? Option 1, you receive $1 immediately. Very good, Luxo, I'm glad. Thank you, Sever. Sever? I need to learn all your names. I need to be able to pronounce them properly. Okay, so which one do you prefer? Option 1, receiving $1 today, or option 2, receiving $1 in one period from now? You can write your selection in the chat. Do you choose option 1 or option 2? Okay. Option 1, option 1. Okay. So is this a simple question? Okay, so anybody pick option 2? So what is your rationale for option 1? How do you rationalize? It's obvious, but how do you explain it to someone who may not see? You should tell them that I know what $1 is worth today, and to get it right now alleviates any uncertainty about what it might be worth in a future period. Always $1 today is better than $1 tomorrow. Financial markets make it possible for someone willing to forego consumption today or acquiring $1 today by paying a certain price. Maybe if they got a little bit more, they might be indifferent between these two. This the interest that they're asking for to make them indifferent is the idea of the interest rate. Okay? In this case, if I put an I here, someone gives me a return for every $1, maybe I'll wait. Okay, if this is more valuable for me to compensate me to wait, maybe I'll wait. So let me say, to make it clear, so option 1 is better. The reasons are let's write some reasons down. So $1 today has greater value since one thing, prices might rise, and $1 tomorrow doesn't buy the same things. It buys today. So it's dealing with the uncertainty of what's to pass, right? And kind of, it's hard to write 1 and 2 because they're all interrelated, but I will just say the opportunity cost. There's an opportunity cost, and yes, maybe you learned this in economics. There's an opportunity cost. The fact that you have $1 today means even if you don't do it, in one period it has greater value. What is its greater value? Well, because of the existence of financial markets, there's some interest rate out there that $1 is really worth $1 and plus the interest next period. And now I can compare those two, you see? And for sure, option 1 is better. It has greater value. I can compare it in the future. But in finance, what we like to do is we like to compare at time 0. So this is what we're going to do next. So first of all, I want you to realize what I just said. So $1 now, if I needed to compare it at time 1, how do I compare it? Well, because of prevailing interest rates, I could invest that or save that or do something with it in financial markets to earn something with it. If I waited, I've lost that opportunity. I represents the opportunity cost. Okay? So to be compensated, if someone was to tell me, well, you have to wait, I need to be compensated for what I would lose. That, in particular, it's that return. Okay. Let me see if you have comments. No comments. Right, you can invest immediately. Right, you can do something immediately. This is really important in finance. It's the value and opportunity cost that creates value, right? So what about this? So if you look at time 1, clearly option 1 is better. But I should be able to make the same argument at time 0. How do I determine what is the value of $1 today? This is what we're going to do next. What's the value of $1 today? So how can we think about this? In terms of financial markets, let's say we know we're getting $1 in 1 year. For sure. We know we're getting $1 in 1 year. And because of that, along with the existence of financial markets, there's a prevailing interest rate out there. I know I'm getting $1 in 1 year, so I can borrow against that $1. I know I'm getting $1, so I can borrow some money now through financial markets, and then return the $1 later when I get the $1. We say we borrow against future $1. So we use the term we borrow against it. We know it's coming. So how much can we borrow that is the value of $1 in 1 period from now? Does anybody know what that amount would be? This very simple example is finance in action. And I should come with the same conclusion. I should have the same conclusion that clearly option 1 is better. Nobody knows? How would I figure this out? Okay, let's go to our time value of money expression. Okay, I'm going to skip this one. Okay, I'm going to skip over all of this. So let's look at this example on page, and I'll go back. Uh-oh, someone's car alarm is going off. Okay, slide 13. Thank goodness. Okay, slide 13. $1,000 is to be received in 2 years. Okay, so this is even more complex. The other one's simpler. What is the value today of this amount to be received in 2 years? The prevailing interest rate we're going to use, the appropriate one, is 8%. So we'll just assume there's 1. Okay, and that's what I put down here. So what is the value? Well, we know that we have a formula. Future value at time t equals present value at time 0, 1 plus I to the t, right? We know that. But this time, I'm interested in not in the future value, I'm interested in the present value. So isn't this simple algebra? This would be future value t divided by 1 plus I to the t equals PV. Whereas what we did before was known as accumulation and accumulation factors, this is known as discounting, or the discount factor. So what I want to see from you in a test situation is I want you to be able, I don't want you to write these formulas, I want you to apply the formulas. It means that I want you to write 1,000 over 1.08 to the power of 2 is equal to what you want. I'll make that a little neater. So again, you can put this in your calculator and sort it out. So we've exploited this, we've used this relationship to find a different variable. Rather than finding the future value, I want to know what's the value today. And then we'll talk about the interpretation and go back to what we were talking about earlier. So here we have $1,000 divided by 1.082, and this is the present value at time 0. This is called the discount factor. And to calculate it, let's just use the scientific keys. We're going to go into TVM keys in a moment. Let's do that in our calculator. Now this is on the bottom. So what I'm going to do is, with my calculator, I'm going to type 1.08, and I'm going to use the power key 2. We've seen this number before, but I need to invert that because it's a discount factor. So I use the key 1 over x, you see? This is just toggling, repeating it. So I'm inverting it. Now it's on the bottom, and then multiplying by 1,000. So 857.34 is what I'm going to transfer to the page. It's 857.34. So this is worth 857.34. So I'm going to wait for you to catch up, and then we're going to discuss what this means. Is that the right number? So this is algebra, but finance is understanding it, okay? Finance is understanding this. So it says that I know I'm going to receive $1,000 in 2 years. So right now, with 8% interest rate available to me, it means I can borrow $857.34 and then pay back the 1,000 with the money I'm getting. I'm receiving it from somewhere. I don't know if it's my employer's going to give me a bonus, or if I have some inheritance coming, or I know I have a rental property and I know that money's coming to me from my rental property. So it means that today I can borrow $857.34. What I do with it probably should be smart. I should probably do something smart, invest in something, or try and grow it, beyond 8% return, make some money with it. And then it's not too much of a concern because I know I'm getting $1,000, and when it comes in 2 years, I just pay off my debt. Okay? Don't go to the casino with this. That's not a good idea, right? Well, maybe you could. Maybe you want to go earlier than waiting to go to the casino in 2 years and just enjoy yourself. But don't spend more than $857.34, or else you're going to lose money. So my point is, $1,000 in 2 years is worth $857.34 now. That's its value. So if I take this back to my blank sheet, where's my blank sheet? What is the value then of $1 today? The value of $1 today, I'm just gonna write at the top here. If it's $1 we're getting, we need to discount that to know what it's worth today. And that is definitely smaller than $1. So we see clearly option 1 is better. So what I've done is I've explained that option 1 is better if you look at time 1 or you look at time 0. The very fact that I have to translate these values over time is an example of the time value of money. Okay, so now you're asking me about how do I know about these rates? Okay, so for these examples, we assume the rate stays the same, okay? But in reality, of course, there's risk. Rates can change. But this is a very basic understanding at first. We got to start with a basic example. So in the basic case, when I give you rates like here, we assume that 8% at time 0 through 1 through 2 is the interest rate we're dealing with, okay? And there's only one that we're looking at. The fact is, I could, if there's another interest rate, I could borrow this money here and invest it somewhere to get a higher return. So I can borrow, usually the borrowing rate is higher than your investment rate opportunities, but anyway, depends. But in this world, I've presented one interest rate. But presumably in reality, if you can borrow against future earnings and earn a higher rate than your borrowing rate, that makes sense. It's risky. You might not get that return, but in this case, the way I've done this is certain, 100%. So good questions. Okay, so let's go backwards and do this for people who are struggling to understand. Let's go back here. So we started here, and I'm just going to check if there's anything down there. Okay, so that's that slide, and then I added this slide. But what I wanted to do, so this is a summary of what we did. Here are the formulas, and here is what I want to see. I want to see you enter the values in the formula and get your answer. That's what I want to see in a test situation. What I want to do now is we're going to use the TVM keys of the calculator to do this. You're going to see how helpful this is. But I don't want you to forget the formulas. You need to know those as well, right? The formulas are programmed into the calculator to make these calculations. All right, so how will we do this? If you notice, from left to right on your calculator are these symbols. N represents the duration of the investment. We use a T in our formula. Hope that doesn't bother you, but that's the idea. So this is, let me make this a little bit bigger. So 2 periods. 8 is the interest rate. Notice I don't use decimals. I enter it as a whole number. So that's for interest. Why am I doing this? Why did I put a negative 1,000? I'm putting a negative 1,000 because I'm investing. I'm investing, so it's a negative cash flow. It's out of my pocket. Okay, we say out of the pocket. Okay, so then that gets a negative in the calculator. You put that into the present value or the principal value amount. And then you tell the calculator there is no payment. This is some concept we're going to get to, but this problem does not involve any interim payments. It's just a simple lump sum investment and immediately. And then you ask the calculator, after entering 0 into payment, you go to the compute button and you ask for the last key, the future value key, and you get your answer. And this is an example of accumulating to find a future value. So let me show you on the calculator. We'll do this together. So on the calculator, we begin with the TVM keys. I'm going to enter 2 into N, going left to right, 8 into interest, and then PV is the 1,000, but I have to put a negative in front to tell it I'm investing, so then it can tell me that I've got a positive dollar return, right? That's what's going to happen. There's no payment in this problem. It's just a single lump sum investment. And now I'm going to ask the calculator to compute. Your compute key is in the upper left corner. Compute. And you say future value. And you get your answer as a positive cash flow. Remember, if the screen goes blurry, just to refresh the screen. And that's your answer. We already saw this number. Any issues about that? Okay, so also in the questions in the chat, somebody's asking about where does the rate come from, right? The rate is a result, the prevailing interest rate is a result of a negotiation. It's a result of a negotiation between people. One person who's prepared to give up their money, this person here will only do so if there's an 8% rate. On the other end of that deal is a company or another individual willing to pay them 8% because they possibly believe that they can earn even more than that, pay back this individual, but then do something more with that than the 8%. Or this is actually a result in equilibrium. We say in economics that this is the fair price because this person's willing to give up, and on the other end, the other person is willing to pay out this amount for consumption immediately. Okay, so it's equilibrium result of supply and demand for capital. And that's from economics that you learn that. So where does the interest rate come from? It's really a negotiation that happens among investors. Sorry, not sure where to write it. So the interest rate is a result of different types of people. One prefers consumption today and is willing to pay for it. But the other is willing to forgo consumption for a price. It's the negotiation of that price, what this person's willing to pay, and this person's willing to give up, for a price. It's that negotiation that creates the interest rate. Okay, let me make the calculation again. So it really happens in the markets with groups of people, right? Their willingness to forego consumption. So it's really different types of people make it so. All right, you have the borrowers and you have your lenders. We need them both for markets to exist. So let's go back to making the calculation one more time. So let's see. Clear the screen. Let's do clear TVM for fun. Second, clear TVM. Okay, it's clear. 2 into n. 8 into interest. You have to press the number first and then the key. 1,000 with a negative in front for an investment into PV. There are no payments in this problem, so I put 0 in PMT. And then I asked to compute FV, and that's my answer. Okay. Okay, so we've done this problem. And then here are the results from the discussion of simple interest and compound interest. And here is the discussion about finding the present value. Okay, so what I did here was just use the formula, leaving the PV blank. That's what we want to find. And I make the calculation with the formula here. And now let's use our calculator to do the same thing. 857.34, correct? So let's use the calculator to do the same thing. So all these things I've been writing, they're in the notes, except for the discussion and the written part about interest rate and the time value of money. Oh, so these are all the same exercise and very repetitive, all the same, all the same, all the same. Okay, so here we are, slide 18. Let's put this in our calculator. Yes, that's what we're going to do now. Very good. You asked me. So this is the question. So let's put this in our calculator for this problem to find the PV. To find the PV, you can do it algebraically, like we did, but now let's use the TVM keys. So going to the calculator, clear second, clear TVM. So we know it's 2 years, so 2 into n, and the interest rate is still 8 into interest. The present value is what I want to find, so I leave that empty. There are no payments, again, no interim payments in this exercise, but I know the future value is 1,000, so I put 1,000 with a positive because I'm receiving it into future value. And I asked to compute PV. And there you go. That's my answer, 857.34. $857.34. And there's a negative in front because that means, well, if I'm receiving, it's implied that I'm, so the calculator is working with investments, right? So if you're receiving that amount in the future, then it's worth $857.34 today, but it's treating it like you accumulated it from somewhere. Okay, so you by $857.34 invested, that's the negative, you're going to get 1,000. That's what the calculator is doing. So you got to be smarter than the calculator and know what you're up to. So you don't, even though the calculator shows you a negative, it's 857.34. So there's two ways to interpret this. Let me summarize with this. Getting getting $1,000 in 2 years is worth $857.34 to you. That's the value today. You would be willing to spend that amount with 8% prevailing interest rate. You would be willing to spend that amount to make $1,000. It's another interpretation. So let me see. So to interpret, So 857.34 invested today would grow to $1,000 in 2 years. Alternately, so you would be willing to spend 857.34 to get the 1,000, right? But if you were getting the 1,000 and you didn't have to invest anything, $1,000 in 2 years is worth 857.34 today. Looks like the same statement, but in this case, this is the example I gave you that you could borrow against. You could borrow 857.34, knowing you're getting 1,000 in 2 years. So I didn't tell you either story clearly, right? I just said you're getting $1,000. What is it worth? Either of these interpretations fits. The calculator doesn't know. It's just telling you if you put $1,000 to be received, you'd have to pay $857.34 for it. It doesn't know where that money's coming from or what that money's about. Okay? The point is the value is $857.34 today. So let me just make that thing 1,000 in 2 years. So you just have to be able to interpret it for your problem. The calculator doesn't know. It's not AI intelligent. 1,000 in 2 years. So this is the interpretation the calculator is using. That's why it gives you a negative. But it could just as well be this interpretation, and you just don't worry about the sign. The sign is just to keep track of inflows and outflows. Question. We refer to this as discounting, right? Discounting to find the present value. All right, next. You ready to move on? So I have used the time value of money formula to solve for the future value of an amount accumulating at an interest rate, and I've also used the time value of money formula to determine the value of future cash flows today. What if I'm interested in a different variable? There's other variables, right? Let's write the formula again. Well, the formula's right here, so let's look at it. So far, I found future value using all the other variables given. I found present value using all the 3 other variables given. So let's look for a different variable. Let's look for I. Can we find the interest rate implicit in an investment? Here's an example. A financial security sells for $900 today and promises to pay $1,000 in 2 years. So what is the return, or the rate of return on this investment? Now this is important because I want to compare investment opportunities, and maybe they're presented to me with rates of return or expected rates of return, so I need to compare mine against those, right? In this case, $900, I can buy a security, so some sort of investment product for $900 today, and it's going to give me $1,000 in 2 years. All right. So if I put in the variables that I have of future value. That's not the 1,000. I have the present value, which is 900, and I have 2 years here. So I have everything. I just need to solve for I. Now you can do this algebraically, right? You can solve for I. Let's do that on the side here. Let's solve for I. So we have 1,000. I'm going to do this without skipping steps. So I can continue, so this cancels with that, and it gives me 10 over 9. 10 over 9 square root minus 1 equals I, correct? Or let me put a red square around it. And when you put that into your calculator, 10 divided by 9 square root minus 1, 10 divided by 9 equals square root minus 1 gives me 0.054, this number, right? So let's, I can times it by, I can multiply by 100. So it's 5.4092, sorry, 9255. Okay, I'll write that down. So I mentioned to you, we want to keep as many decimal places as we can. Usually you just follow my directions. I don't have directions here, I'm instructing right now, but in the exercises I give you, you just follow the instructions of how many to report. Yes, Samuel. The discount factor can be accumulation factor depending how you use it for FV or PV, right? Okay, so 5.40922, sorry, 9255. So I is equal I'm going to forget. Let's do that again. 409,255. 409,255. That's actually my final answer. Okay. Oh, that's a percentage. So this is 900 cash outflow to receive 1,000 cash inflow. Let's find the interest rate using the financial calculator now. Let's see if you can do that. We should get the same answer. The trick is getting the signs right. 900 has to have a negative in front, and 1,000 has to have a positive in front, or you will not get the right answer. So let's see. TVM keys, 2 periods. It's 2 periods, right? I'll have to go back and check. It's 2 periods, 2 years. Notice I keep saying periods just to be careful, because it's not necessarily always years. It could be months, it could be days, but right now it's 2 periods. And the interest rate is what I want. I'll leave that blank, and I enter in that it's a present value of 900, and I use a negative sign to enter PV. Then there are no payments, so I put a 0 in here. And the future value is going to be 1,000, and I receive that, so that's a positive. And now I ask to compute I. You see the number? Looks familiar. It is the same number, and it rises as it's computed as a percentage. Do you need me to do it again? One more time. So let's clear TVM. We don't have to. If we remember to touch all the keys, we should be fine. So I'm going to say 2 years. Interest is what we want. We leave it blank. PV is 900 with a negative as though it's an investment. 0 into payment, and then we get the 1,000 as a positive, and we ask to compute I, and we get that number. All right, so I have the instructions there in the notes, how to do that. Now for a test situation, what I want to see is, I want to see you write this formula with the values inside, and I want you to give me the final answer. Here I rounded it to 2 decimal places. I don't need to see this. This will get you no points, all right? There are no points, for demonstrating keys or TVM keys. Okay, there's no points for that. You can write it down if it helps you. You should, but I'm not going to give you any points. The points are here and here. You won't even get points for, no points for the formula. You have to actually have the formula with the values included in it. So you should be able to use your calculator, you should be able to write this down, and you should be able to solve it mathematically like we did, and I trust you can solve it analytically as we did. So that was just like the algebra. Okay, so you guys are quiet. Is that one okay? You got the hang of this? Can I move on? Did you get the right answer? You will get an error if you didn't make these different signs. Doesn't matter. I mean, for the storyline that I just told, this is a negative and this is a positive, but even if you inverted them, you should get the same answer. The problem is making them both positive or both negative. That's a mistake. Okay, our last variable. What about finding time? How long does it take an investment of $1,000 to become $10,000 if there's a prevailing rate of return of 8%? Same formula, but now we have the future value, we have the present value, and we have I. It's t that we want. So again, in a test situation, I want you to write out this amount and give me the answer. Now, if I asked you to show your work, you would have to do the algebra. So let's show work. If I ask you for that, you should be able to demonstrate the solution. So it's 10,000, sorry, equals 1,000, 1.08. and t. I don't know what t is. But if I divide 10,000 by 1,000, I have 10, and then 1.08t. So I could take the logarithm of 10, and then that is equal to t times the logarithm 1.08. I hope you remember how to do this. You see the value in it. Now, this is natural logarithm of 10 divided by 1.08, and that is t. So t is calculated like that. And I presume you see already how much easier it is to use the TVM keys. But you need to remember this stuff too. So what do you get? Very good. Sévère. Monsieur Sévère, you get 29.9188. Very good. So this is 29.9188,402. So for people who don't know how to key that in, it's log 10 divided by natural log 1.08. So natural log 10, so you would write the number first, divided by I think I have to use brackets. No, I don't remember the number. It's 1.08. I did remember, but I'm not sure. So 1.08 log, close the bracket, and there you get your answer. Should I do it again? So it's clear. So it's log of 10 divided by natural log of 1.08. So it's 10 log divided by brackets 1.08 log. So the number first and then the function. And there you go, 29.91. How's that, Alain? One more time. 10 natural log divided brackets 1.08 natural log, close the bracket, and then say equals. I hope that's okay. All right, now let's do it with the TVM keys. We can store that to prove it's the right answer. So I put store 1. So let's see. We know that we don't know n, so we'll leave it blank. From left to right, now interest was 8. The present value was 1,000 and the future value 10,000, right? So the present value is 1,000. The future value, should I put a negative? Negative. And the payment, there are no payments. The future value is 10,000. Oops. You can use the arrow if you go too far with entering values. Can delete, you see? That's your future value, and then ask for time. So sorry, second, what did I just do? Second, compute and equals. What did I do wrong? I think I lost everything. I think I erased everything. Okay, do that again. That's fine. So interest is 8. Present value is 1,000 negative. Payment is none. And the future value is 10,000. Then I asked to compute N, and that's the answer. Sorry, it was confusing what happened there. Do it one more time. So interest is 8, so N is the one I want, so I don't put anything in there. PV is 1,000. Investment. Payments are none, 0. And then 10,000 is what I earn, positive, and I asked to compute N. Okay. So those are the steps. It's in the notes. You have the notes. Oops. I have all the steps here, and so we interpret it as 29.92 periods. In our case, it's years, so we say 29.92 years. And we also solved it analytically with algebra. So what you need to remember here are the signs. You have to make sure you have the sign right. That one negative and that one positive. And keep in mind that no points. On a test or assignment, you have to show me the formula and your final answer. That's all I need to see. Unless I ask you to show your work, means show the algebra. Okay, no comments? Next. In summary, we have these two expressions that I will refer to as the basic time value of money relationship. You can write it this way, or you can write it this way. They're the same relationship. T represents the duration of the investment. I represents the implicit interest rate. PV is present value or principal amount invested. FB is the future value or the accumulated amount. And notice we use this formula to go from end to end, which is all the problems that we did were end of the period values. Remember the difference. But you can also use them if you're going with cash flows from the beginning of a period and you want to know about the cash flow in the beginning of a new period. All right, so that is my summary of time value of money. Now, I want to show you, I have also sent you a formula sheet. So these are the formulas that you'll need by the end of this weekend. You should know all these formula. The first one, so you can use this as a summary. The first one is what we just discussed, the basic time value of money formula. And I show you 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 can discount taking the future value back to time 0 as a present value, or you can accumulating present value of 0 to become future value at time t. So that's what we do with this. Notice there's nothing intermediary happening. That's the idea of the payment. There's no payment. There's nothing intermediary. Okay, the next one we're going to talk about is the net present value formula, or mixed cash flows. All right, how's everybody doing? Should we stop here or should I go ahead? I don't know. Let's see how excited you are if I continue, because it's 7:41. Maybe I'll go just to introduce this, and then I'll let you rest. For tomorrow, I'll send you some more notes, maybe. I think we still have quite a few to do here. Maybe the review exercises, I will send them for Taylor for tomorrow morning. You'll work with Taylor, I think. That's how it's been planned. You can review these notes and that. Okay, you guys are not commenting, so I'm going to just go back to the notes and do what's called the net present value. So here's my exercise. You believe that if you buy a hotel for $3 million today, you can sell it in 5 years for $4 million. The interest rate is 8%. Should you buy the hotel? I presented the timeline, and I've shown you the purchase of the hotel at time 0, and then the value of the hotel at time 5. Now, in terms of finance, we want the economic value of assets. Okay, so initially this is a cash outflow, so this is a negative 3 million. And then even if we don't sell the hotel, it's going to be worth 4 million by year 5. So when we think about options, we contrast it against the opportunity cost. What else could we do with $3 million? We could buy the hotel, or what's left? What else could we do? It's a very simple problem. Whenever I present you an interest rate, you understand the opportunity cost of doing nothing with your money, that you are foregoing an 8% return. So you could have taken $3 million and invested in financial markets. However it is, invest or save, this 8% that exists, you want to capture that. So you need to compare 3 million against 3 million that turns into 4 million against 3 million that turns into what? So let's see. We should compare it then. Call this option 1. And option 2 would be so you're going to invest it in financial markets. Right, so I'm going to do it this way first, Jefte, and then I will do it that way, okay? So you could take 3 million and see if you invested it, what would it become? It will become 3 million and 5 factors of the accumulation factor 1.08, so that when you put that in your calculator, you can do it with the time value of money keys, or you can do it with the scientific keys. What do you get? Right. So, good. So if you compared it this way, this would become 4,407,984 and 23 cents. So it looks like option 2 is better. Right? Because that's more than 4 million. So you need to compare these amounts, this one 4 million against the 4 million. So this is just working in the housing market, and this the hotel market, housing, real estate, let's call it real estate market. And here would be operating in the financial market. Now, obviously, they are interrelated because you usually borrow money to invest in real estate. But just saying, this is what we're comparing. Real estate investment versus financial market investment at 8%. And there's only one interest rate. Remember, I made this simple. So in this case, you should not buy. So you know the answer. Don't buy the hotel. Very good. You guys got it. Good, good. Very good. Okay, I see the chat. You're doing well. So that is the logic. What's another way to look at this? What's the finance way to look at this? I mean, it looks like I use finance because I did, I used the time value of money formula, but what we do in finance is we like to value assets at time zero, like now, because we know what money is worth today. We know what it buys, okay? So rather than looking at the future value of these amounts, so this is the future value for year 5 of both of them, why not the present value of both of them? So rather than doing that, let's get the present value of $4 million and compare it or offset it by the initial investment. In doing it that way, we are going to incorporate the idea of getting the net amount, but using the opportunity cost of $1 to value that 4 million. So we're putting everything into one problem. So next class, because it's 7:50, we're going to stop. We're going to pick up here, okay? Now you can, tomorrow, you can work a little bit with Taylor on these topics. But I'm going to stop here. Not sure why there's a huge noise as well. I have to investigate what's going on. Why is it so noisy? Okay, so you guys can see what I have here is called the net present value. This is the symbol for the initial cash flow. And this is the present value of the future cash flow of the $4 million. And I offset them to find the value of the project. The rule is that the net present value greater than 0 implies to invest. In this case, it will not be greater than 0. We already proved that. We already know that from carrying out the exercise in a different way. So the rate that's set up, you guys are asking me about the rate. The rate is the prevailing interest rate that you consider. Now in this world, I only gave you one. It's just available. It gets set up, as I explained before, it's set up by the willingness of people to forego consumption. And that's the price they're willing to forego it for. So they're willing to give up money today as long as they get 8% return for every year they give it up. So it's figured out in the marketplace. There are interest rates that are figured out by all market players. And maybe you guys want a lesson in interest rate. Maybe I can squeeze that in. But basically, it's an equilibrium between the suppliers of capital, like the lenders, and the borrowers of capital. Okay. So in reality, there's many interest rates that exist, and the higher the interest rate usually means the more risky the investment. We're going to get into all of that later, but you guys are asking very good questions about the interest rate, and we can talk about that more tomorrow. Let's see if I can have another way of explaining it to you. But for now, I'm just giving it to you so we can make these calculations, but it is a very interesting theoretical question. So it turns out that when you do this, and I show you how to do this on your calculator. So we'll do that fresh starting tomorrow. You guys can practice, if you can follow this description, how to do this on your calculator. It shows that NPV is going to be a negative, so you should not invest. But we already know that from the previous problem. You mentioned the 407 Harry Charles. The 407,984.23. You should mention that that is the value at time, yes, the opportunity cost at time 5, right? You always have to be careful about mentioning dollars and the time frame, or where the period in time where it occurs. Okay. Oh, that noise. That was a very loud noise. All right, so I'm going to say good night to you, and I'm going to see you tomorrow afternoon at 1 o'clock, and we'll pick up from here. Okay, we'll work on making the calculation. Making this calculation in the calculator. How can you apply these calculations? Well, this is a course where we're going to learn these tools, and you can apply it making the relevant assumptions. We have to learn these first, and then you'll see where it applies. Okay, look so. You guys are very anxious, which is good. There are lots of tips here. We're going to learn about mortgages. We're going to learn about investments, valuing stocks and bonds, and valuing projects. So we have a lot to learn. Hopefully you can use it in your personal life. There's lots here for personal finance. and professional corporate finance. Good night, Jeffson. I'll stay back if some people have other questions. And let's see if Flores or whoever made the video can send it to me so I can post it up here as well for the beginning of the class. Thank you, Canole. Thank you. In terms of tomorrow morning, we're not meeting in the morning. I meet you at 1, but I think Taylor was going to be available in the morning. I don't know if it's too much. Yes, tomorrow afternoon I'm meeting you at 1. The schedule is 1 to 4 because I have another class in the morning. This is what's happened. So I'm going to meet with you from 1 to 4 and then 5 to 8. Unfortunately. So the idea was that Taylor would be available to you to answer questions. I'm not sure if they're going through with that, but I will write them and see. I sent Taylor I sent Taylor the notes as well, so he has them. I'm going to send some review exercises, so if you want in the morning, see if you can meet as a group and work on that. But it's probably all too much. But maybe it's okay because you guys can work on it, on the exercises together, but don't burn yourselves out. That's my concern. Okay, good night.